Okay, so let us go a little bit into a deep dive on AWS networking and networking in general. So in this diagram, I have a AWS cluster. Let's say I have an AWS account, which is, let's say, on the and it has. I'm just showing a multi-region, but basically, what I'm trying to show is that there is a region, you know, which is like they have regions all over the world. So I've just picked US East 1 and US East 2. So these two regions are spread in two different locations, like, and then within a region you have availability zones, AZs, which we call. So each AZ will have a set of data centers. So, and each region can have multiple availability zones. So this region can have three, and they can have as many, and because they'll be spread, they have like a certain number of data centers. So that's what composes a availability zones. And there is a VPC, which is a virtual private cloud, which is basically it's a concept of a virtual cloud service, virtual private cloud, which will be a set of CIDRs, like IP addresses, a range of IP addresses, which will be spread across the AZs. And each VPC can have one or multiple subnets, and these subnets can be public or private. So if it, and that's where inside the subnet is where your EC2 and the workloads will be running. So the subnets can be public, so which means it's accessible from the internet. And if it's private, that means there is no route so if we go back and check in the routing tables, I was showing in the previous slide, in the previous section, there will not be any route for any connectivity outside. And there has to be in the routing table a NAT gateway, which will let the connection to go from this private cloud. And there is an internet gateway which will be a part of the VPC, which is basically the connectivity to the outside. And then we also talked about security groups. So security groups can be one or two, but they're not specific to a particular subnet or AZ or anything. They're basically a set of rules that define the connectivity. So like open access from this particular CIDR range for port 22 from outside, or from port 80. So that security group can be used across different, because it's just a set of rules, right? So then it can be used in different regions also. So then it will have the same set of restrictions that you want to have in this for this set of region for here also. And another thing is like, there is a route 53 is something which is kind of a DNS, right? Domain name service. So when you hit a service, the route 53 can be used to split traffic the way you want it, like 50-50 or 100-0 or failover between two regions. And when you hit the load balancers on each of the regions, then route 53 will let you split the traffic. So when you hit it, it will send half over here, half over here, and load balancer will take the traffic. So load balancer has to be in a public subnet because it's coming from outside, and your workloads can be running in a private subnet. Okay, so before we go next level, let's talk a little bit about EC2 and ENI network interfaces. So as you see here, I have three EC2 instances. One of them is running, two of them are stopped. And this is my instance ID. So each EC2 instance has a ENI attached to it. That is elastic network interface. That is what it gives. It's kind of a network card which gives it a network connectivity. So if you see, this is my instance ID, right? It has a public and a private IP address. And if I go down in the networking, it has a public and a private IP, and it is in a subnet in the VPC. And if you come down further, you will see that it is attached to a network interface. So if I click on the network interface, and if I do this, I have three network interfaces because I have three EC2 instances. Each of them is attached to one ENI, and an ENI is specific to a subnet and availability zone. So if you see, it has different security groups attached to it because it will depend on what I attach to my EC2 instance, right? And then if you see, they are all in use, right? Because I have three of them, and each ENI if we look at the first one, this one has So it has so one of the two of them should have only private, and the last one should have one public IP and a private, because only my cube master is in the public subnet, and I because that's where I'm SSH2, and my private two worker nodes, they are not in public subnet. So if you see my this ENI, it has only two private, and if we look at the next one, if we come down, it has private and public. So this is my ENI that is being used for, and it has a MAC address, and then this is the one that's being used to for with the master. So now let's focus on the load balancers. So in my diagram, if you see from my route 53, which is my DNS, I am pointing the direction to load balancer, and I marked it as ALB. So there are, if you can see in my console, if I go back to see, I don't have any load balancers, but if I want to create a load balancer, see, there are different three main kind of load balancers: application load balancer, network load balancer, and gateway load balancer. There used to be a classic load balancer, but they have deprecated it for now. So these are the main ones, and this is the application load balancers. So the application load balancer, and it has been explained very nicely, it routes the traffic from outside at the application level. So HTTP and HTTPS requests would come to the to either your services or containers or Lambda, whatever works, whatever your application is running on. So if you go back, to here, so here I am trying to use the ALB, and now when the traffic hits the application load balancer, it has to balance the load. So if I have the data, if I have my services running between two EC2 instances, then I need to provide a target group, which is where the health check, the ALB does a health check on a port 80 where your application is running, and it makes sure that if the application is up, only then it will route the traffic. Otherwise, so if I have multiple, and if one of them is down, then the target group, then the data is only sent, the requests are only sent to either of them which are healthy. So if we go back to here now, if I want to create a load balancer, it's an application load balancer. If I do create, right, there are a couple of steps, as you can see, but it can be internet facing, so it can be dual stack or IPv4, which means it will accept IPv4 requests, but internal inside the cluster they can be IPv6 services. It has to be attached to a VPC, and it has to be in a public subnet with a security group, because you're getting requests from outside. So it has to have a security group which will have 0.0.0.0/0, everything open on port 80 and port 443. Then only it will be able to route the receive the incoming request. And then yeah, so that's the default security group usually has that, right? If you can, and then you have to provide a target. So I'm going to right now I don't have a target group. So once I have an app running, it will have a target group, and then the load balancer will be able to reach it. But I wanted to just go over first the details of each of the load balancers. So application load balancer runs at the application level, HTTP, HTTPS. Network load balancer runs at the net. It accepts network, right? Network layer, so TCP, UDP, and TLS for security. So like here it is HTTPS for secure connection. Here it is TLS. So network node balance, most of the time ALBs are very popular because it lets you route the request even path based. So if you have a domain like example.com, you can receive requests for /example.com/services. You can have example.com/utilities, stuff like that. So it allows all the path based routing also, and it also has a redirection, so from HTTP to HTTPS. So it's one of the very popular. So next we will so in my diagram I have shown ALB. So now let's go as to understand what are the features of network load balancer. So network load balancer, as you see, it accepts TCP UDP traffic, and also one good thing is you can have an ALB after your NLB. So NLB is it gives a very high performance. That's why NLBs are very popular, and they work almost the same way as ALB. But if you can see, it's at the network level, right? So if you want to create it, it's the same process. But if one difference, if you can see over here, once you choose the subnet, it gives you an option to choose the IPv4 address, and it allows an option of using an elastic IP address. So this option was not there if this was my application load balancer. It just gives an IP address assigned by AWS, but NLBs give you an option to choose an elastic IP address. So that's very good in the case that you have an external, you have a load balancer with an elastic IP. Then even if your EC2 instances or anything changes, your elastic IP still remains associated, so that the it doesn't affect the incoming traffic. And another one difference is in the security group. So if you see over here, the security group, it is going to choose from the security groups of the EC2 instances. In the case of ALB, it has to have its own security group. So other than that, yeah, these are the two key differences. And then next we'll talk about the gateway load balancer. So gateway load balancers, as you can see in this diagram, it's exactly what it is. The gateway they are the latest ones introduced, and they are specifically used if there is a fleet of the third party appliances that are support Geneve on port 6081 before the traffic is routed to the target group. So in this case, it's basically to improve security and compliance and policy controls. And the target, after that, it's the same. It uses the EC2 instances to route the traffic, and it sets up the target groups.